Hello. Now, today we're going to be looking at inequalities. So inequalities are an idea we've dealt with several times before, and it is going to be where we're dealing with things that are less than or greater than each other. So right now I have 8 is greater than 4. So this symbol here, the sideways looking V, means that the larger thing is on this side, on the larger side of the symbol, and the smaller thing is on the smaller side of the symbol. So 8 is greater than 4. And that's true. 8 is bigger than 4. It's greater than 4. Now, if I change this around a bit, I could subtract 1 from both sides. Or we'll say I could subtract 2 from both sides. And I end up with 6 is greater than 2. That's still true. So again, this means greater than. The bigger side is pointing towards the bigger number. The smaller side is pointing towards the smaller number. And this is what's called an inequality. So we're used to having equal signs in between things. Now we're going to have this bigger than or less than, greater than or less than sign in between our different symbols. Here we just have numbers. So 6 is greater than 2. Could I multiply these by anything? Well, let's try. See if anything breaks if we multiply both sides by 3. I'd end up with 18 is greater than 6. Well, that's also true. 18 is a bigger number than 6. What would happen though if I write it again up here? So 18 is greater than 6. What would happen if I multiplied this by -1? So I've been able to do multiply before and it didn't cause any problems. But what happens if I multiply by a negative number? I end up with -18 is greater than -6. And this is a problem because it isn't true. As numbers become more negative, as we move down to the left on our number lines, we get to smaller and smaller numbers. So our numbers are getting bigger as we go to the right. So in the same way as 1 is smaller than 2, -1 is smaller than 0. So -18 is smaller than -6. So when I've multiplied by this -1, I have to go in and flip my sign around. And I have to say -18 is smaller than -6. So this is an important thing that happens. If we multiply or divide our inequality, our greater than or less than signs, by a negative number, we end up having to flip our symbol around. We have to flip our symbol to the opposite way around. So that's our idea for inequalities. The other thing we need to refresh ourselves on is the meaning of our 3 terms here, n, z, and or. So capital N stands for all of the natural numbers. That's going to be the numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So they're positive whole numbers. They start at 1. 1 is the smallest natural number, and we keep going on up, counting in whole numbers. Z stands for integers, and that's all of the positive and negative whole numbers and 0. So it includes -2, and it includes -1,000,000, and it includes 0, and it includes +10. So all of the whole numbers, every whole number we can think of, is an integer. And lastly, we have the real numbers, and the real numbers are all numbers. So including fractions, including any difficult or complicated number we can think of, all numbers are real numbers. So we're including fractions and stuff like that. So it's not just the whole numbers like 1 and 2 and 3 and 4. It's going to be a half and a quarter and 8/16 or 32 91ths. So all of the awkward fractions, every single number we can think of, is a real number. Now, when we're talking about inequalities, we're often going to want to talk about number lines at the same time. We could see when we were doing our initial discussion up here that it is we're often going to want to refer to number lines to talk about number lines. So what we're going to do is look at what this looks like on a number line. So what does this mean if we said it out loud? X is less than or equal to 5. So here I had 8 was greater than 4, and there was no little line underneath here. But here I've got x is some number. I don't know what x is, as I often don't know what x is in algebra. So x is some number, and it's going to be a number that is 5 or smaller. So x is less than or equal to 5. So let's draw this on our number line. So x could be equal to 5. So I'm going to put a dot on the 5. X could be equal to 5. And then x could be any number that's smaller than 5 as well, because x is less than, is smaller than or equal to 5. So it could be 4, or it could be 3, or it could be 2, or it could be 1. At that point, I'm going to stop. Not because of what it says here, but because I'm told that x is a part of the natural numbers. X is an element of the natural numbers. It's part of this group, this set, if we remember back to our work in sets. So x is an element of n, and I just talked about what natural numbers are. The smallest natural number is 1. So our group stops at 1. So I don't put any more dots for any x's smaller than that, because they're not in this group. Because x in this question is a natural number, so it stops at 1. So that's how I do my number line when I have natural numbers. If I have exactly the same question, but now x is an integer, so any whole number, x is less than or equal to 5, so it could be equal to 5, so I put a dot at 5, it could be equal to 5, and it could be any number smaller than 5 as well. And this time, because I'm not dealing with natural numbers, I'm dealing with integers, I could have x is equal to 0, or I could have x is equal to -1, and so on down. And that group would keep going. And I don't want to have to keep writing that group forever. So what I do is I put in an arrow, and that arrow tells me this group just keeps going in that direction. And one of the nice things about drawing this is you can see our less than sign here actually points in the same direction as our arrow points, which can be a helpful way to check our answer. So x is less than or equal to 5 when x is an integer, means that we start at 5 and it's any whole number that's going smaller than 5 or equal to 5. Finally, we have x is less than or equal to 5, and x is a real number. So we know that real numbers are all numbers, fractions, and all of the little numbers in between here. So it's not just 5 and then 4, it's 5 and then a little bit less than 5, and so on down, all of the numbers in between. Because of that, we can't draw in dots for our numbers, because we'd have to draw in a dot for every single possible little fraction and every single possible little number. We can't really do that. So what we do is we say that our group starts at 5, because x is less than or equal to 5. X could be equal to 5 as normal, but then we draw a solid line going back in the direction of the number smaller than x. And just like before, we're going to draw in an arrow that says that this keeps going. So absolutely all of these numbers here are possible values for x, because x is a real number. It's any number. So all of the fractions, all of the awkward little numbers in between here are all covered. So that's why we have a solid line going back that way and an arrow. And again, the arrow points in the same direction as our less than sign. Let's have a look at this situation here. So top right of our screen, we have x is less than 3. Now there's no less than or equal to here. So what does that mean? It means that our group starts at 3, but it doesn't include 3. So x is a number that is less than 3. So 3 isn't included. But it is how we start our group. So we want to say that this is how we start our group, but x can't be equal to this number. And we also note that x is a natural number, so we're going to be using our dots on our number line. And what we do is we say that x starts at 3, but it doesn't include 3. So I put a circle here, I put a hollow dot here, and then x is smaller than 3 means that x could be equal to 2. 2 is a perfectly true answer. I could get x is equal to 2, or I could get x is equal to 1, and I can't get anything smaller because I have a natural number, and I know that 1 is the smallest natural number. So if I have less than, it means that my group starts here, but x couldn't be equal to it, so I put a 0, I put a hollow dot there. Now, that's the idea of inequalities. Combined with that, we have inequalities that are very like equations. So we're going to solve these like we'd solve equations, and then we're going to put them on our number lines. So what I'm going to do is solve this like a normal equation. So if I have an equation like this, I want to get x by itself. So I have this minus 3 here, and I don't want it there. So I'm going to add 3 to both sides. And I get 5x. 5x is going to be less than 20. So 5 times a number is less than 20. I want to know what the number is going to be less than, so I'm going to divide both sides by 5. So x is less than 4, and x is an integer. So I can draw that in. I'm going to draw that now. So x is going to be less than 4, and x is an integer. So x is less than 4 means our group starts at 4, but doesn't include 4. And then it can be any number any whole number that's smaller than 4. So I can keep putting solid dots. And why don't I have to stop at 1? Because I'm dealing with an integer this time. So I just put an arrow and say, this keeps going. Now, let's solve this one here. So I have minus 6x plus 3 is less than minus 15. So now I'm going to take away 3 from both sides because I don't want the 3 here, so I'm going to get it to go to 0. I'm left with minus 6x is less than minus 15. Now I want x by itself, so I'm going to divide by the number in front of x, because any number divided by itself is 1. Sorry, 18. My apologies. Minus 15 minus 3 would be minus 18. And then x is going to be less than minus 18 divided by minus 6 is going to be 3. But I've got a problem here. I divided by a minus number. And I remember back from my work at the beginning that if I multiply or divide by a minus number, I need to switch around my sign. So this becomes x bigger than 3. It was less than, and now it's bigger than because we divided by a negative number. So then I'm going to draw my number line. And I have x is going to be bigger than 3. So x, my group starts at 3, but it doesn't include 3. And then it can be any number bigger than 3. And this is a real number, so I'm going to use a line. And x is going to be any number bigger than 3, but not including 3. Finally, I'm going to rearrange this one. I'm going to solve this one to find out what x would be. So I don't want my minus 10 here. I want to add 10 to both sides. So I get 4x is greater than or equal to 24. Divide both sides by 4 to get x by itself. And x is greater than or equal to 6. And I'm going to draw my number line. And then x is equal to 6. X is equal to 6, and it's equal to any number bigger than 6. And x is a natural number, so I'm going to use my dots. I'm going to go, could be 7 or 8. And I can keep going, so I can put an arrow. And again, the arrow points in the same direction as our inequality sign. So that's what we need.